All right, this is the fourth video on counting, and this is now we're going to get a little weird. Combinations. We're going to talk about combinations. Combinations. This is different from permutations for one primary reason. Let's go back and look at our bookshelf, right? We had three books, three different color books on a bookshelf. And I'm using this example to just help highlight sort of the difference. So there's my three books on the bookshelf. And before we had talked about these books on the bookshelf, we said how many ways could I order those books on a bookshelf? Because, you know, I suppose in an interior decorator, it matters whether the purple one is first or the purple one is last, right? It would matter, and we came up with 3 times 2 times 1 before. This was when we were talking about when order mattered, when order mattered. What we had said was we would have 3 times 2 times 1, which equaled to 6. We could actually rearrange those 3 books 6 different ways, and that was the permutations. P-E-R-M-U-T-A-T-I-O-N. So those were permutations. But really, for the normal person, I mean, you're talking about Jane Austen and, I don't know, Moby Dick and maybe Hamlet. They're on your bookshelf. So does it really matter whether Jane Austen is first or last? Not really. It's the same 3 books. So when we talk about combinations, you've got 3 books on a shelf with only 3 spots to put 3 books. So you really only have one choice, right? I mean, whether you put the purple one first or the purple one last, it's the purple one still on the shelf. So you actually only have 3 choices. You only have one choice. So when talking about combinations, well, you've got 3 books in 3 spots, so you only have one real combination to put them in, so the answer is 1. But if order did matter, then it's permutations. So the difference here being if you did NCR, which is combinations of 3 things, choose 3 spots, your answer is going to be 1. But if you did NPR of 3 things, choose 3 spaces, your answer is going to be equal to 6. So those are 2 very different ideas. Down here with combinations, the order doesn't matter. It's the same 3. Here's another example of when order doesn't matter. Let's talk about ice cream flavors. You have 5 different ice cream flavors, okay? We've got 5 flavors. So here they are. Let's go. We've got the red flavor, and we've got the orange flavor, and we've got the yellow flavor, and we've got the green flavor, and we've got the blue flavor. Okay. And the question is you can pick only 3, okay? You can pick 5 flavors, but you can only pick 3 for your ice cream cone. So that's the catch. So now all of a sudden, let's pretend for a moment that the 3 you're going to pick are going to be, let's pick you're going to just do this, the red one, the orange one, and the yellow one. Now, whether you arrange that in red, orange, yellow, or yellow, yellow, orange, red, or orange, yellow, red, or red, yellow, orange, or, well, these ones here, you can arrange them in 6 different ways, but does that change your ice cream cone? Not at all. So you got to be careful not to double count. So what you actually end up doing is you would use that combinations, which you start with permutations. Okay, so here we go. Let's just work it out. So first we've got 5 flavors, so I'm going to pick 3. So you ended up with 1 first place, second place, third place. So you had 5 choices in the first place, and 4 choices in the second place, and 3 choices in the third place. And that's equal to 60. Now again, 60, be careful, because 60 assumes that I can rearrange these and I'm going to end up with duplicates, because, 60 allowed for me to have red, orange, yellow, or red, yellow, orange, where I was just using the same flavors in a different order. So now we somehow have to figure out how to get rid of the duplicates. So I could figure out my duplicates, and that's not so hard. If you took 3 flavors, again, let's go back and just consider this group right here. That's really one combination, but you notice how there are 6 things in there? There are 6 ways that I could have rearranged that. So in the permutations version, it shows up as a 6, but I really want it to be a 1 in combination. So what I end up doing is I take that and I'm going to actually divide it by, I'm going to divide that by 3 times 2 times 1, because again, that's the, which is equal to 10, because I might have just lost a few of you. Let me try to explain this another way. Let's go back to ice cream cones. I'm going to look at 4 flavors of ice cream cones. Here we go. So we got a red, orange, yellow, and green. So I've got 4 flavors of ice cream, but I'm only allowed to have 2 scoops. Okay? I'm only allowed to have 2 scoops. So we can just start trying to list them out here. I could, of course, go with red, orange, or I could go with red, yellow, or I could go with red, green. And then I could also go with orange, red, or orange, yellow, or orange, green. Or I could go with yellow, red, or I could go with yellow, orange, or I could go with yellow, green. Or I could go with green, red, or I could go with green, orange, or I could go with green, yellow. So in permutations world, what that ended up with was you had 2 spots, and in the first spot you had 4, in the second spot you had 3, and 4 times 3 is of course equal to 12, and ta-da, you can count it up. Yeah, there were 12 ways you could do that. But now let's take a closer look at this thing and say, wait a second. Red, orange, and orange, red, those are the same thing, so we got to cross this one out. And then I see, wait, I got red, yellow, and I got red, yellow here. Red, yellow, and yellow, red. Well, that's the same flavor ice cream, so I can cross that one out. So then let's look, wait, this green, red, that's right there. Red, green, and green, red. Those are the same, so we can cross that one out, because I don't want duplicates. I mean, how many unique ice cream cones can I have here? So then let's keep looking for more duplicates. Let's see. We have this one right here, yellow-orange or orange-yellow. Aren't those are the same flavors? So we got to cross that guy out. And then, oh wait, here's another. This green right there. There's another pair that are the same, so we can cross that out. Bam. And then we got another one here. This guy here is the same as this guy here. So I think I got them all. So what I actually ended up with, if you count them out, is 6 unique flavors. So the question is, how do we turn a 12 into a 6? Oh, I have to divide out my duplicates. So the question is, remember, we had 2 spots. So how many different ways could we rearrange 2 things on a shelf? Well, that was 2 times 1, which is equal to 2. So I need to divide out all of my duplicates. So you take that and you divide by 2, and sure enough, ta-da! Ta-da! It equals 6. Oh, now of course you could also just type in, remember this was the NCR because order did make a difference. You know, order, who cares if it's orange or red or orange? Order does not matter. Does not matter. Okay, that's big. So you could say NCR of 4 things in 2 spots, right? Or 4 things in 2 spots, and that's what you could type in. That would also give you 6. Okay? Oh boy, I hope that was fun for you. Anyway, here is an example that I'd just like you to try to do. Okay, so how many ways are there to choose 5 cards from a standard deck of 52 playing cards? Okay, I have 52 cards in a deck, and I want 5. Okay, that's a lot of possible choices. So here we go. We can kind of think about this. I want 5, so I've got 5 spots. And in the first spot, I've got 52 choices. And then in the next spot, I've only got 51 choices, and then 50 choices, and then 49 choices, and then 48 choices. Okay, so at this stage, what I've got is permutations. I've got permutations because I could potentially end up with a king, 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 queen. Or I could end up with let's say a king of hearts, king of clubs, a king of diamonds, and a king of spades, and then a queen of hearts. Okay, I could end up with that, but it would count as a duplicate copy and put it into the counting if I just reordered that same group. If I reordered the same group of something I got and maybe put the king of clubs first, and then so that'd be a second option and a third. So it's going to count a lot of duplicates in here. But I say, you know what? Order doesn't matter here. I want to make sure that I have unique hands. And so I need to find a way to get rid of all of the extra numbers. So what I do is I will actually, so you end up with a whopping total, oh, there we go. You end up with a whopping total of only 2,598,960. I mean, that's a huge whopping number. So I hope combinations, I mean, I guess what? Let's talk about this. Permutations, NPR, permutations for times when, order doesn't matter, right? No, order does matter. So go back, so it's always going to give you a bigger number. Because maybe think about a car. It does matter who's driving, and it does matter, a car. It does matter who's driving, and it does matter who's riding shotgun. It's not the same if you're sitting in the back seat. Yeah, it's 5 people being arranged in 5 different seats, but it matters where you sit because it shows, whatever. But NCR, or combinations, that one is going to talk about when order does not. So that would be like saying, well, you've got 5 seats in the car, so get in. So imagine NC are the combinations. Grumpy Mom says, just get in the car. I don't care where you sit. So really there's only one way to go. Get in the car. There's one option. Get in the car. It doesn't matter where you sit. Get in the car. Or you can think ice cream cones. Whether you put the vanilla on the top, whether you put the vanilla, the chocolate, and the strawberry on the top, or you put the chocolate, strawberry, and the vanilla on the bottom, they're the same thing. right? So combinations will allow you to count these as equals one thing, but permutations would see that as two separate things. Okay, so I hope this helps out a little bit. Here are a couple of examples. Okay, so you've got Bill, and he has 7 classes to pick from, and he's going to try to figure out what he wants to take next year in high school. He's got 7 classes to pick from, and he has 5 periods in the day. How many different schedules could he actually get? So is this a permutations or is this a combinations question, and what's the answer? On this one, you've got 6 different pizza choices, topping choices. Pizzas, okay, so you've got buffet. You can pick pepperoni, sausage, mushroom, green olives. You've got 6 topping choices. How many different 2-topping pizzas could you end up with? Okay, is this a combinations or is this a permutations? And solve the question. Good luck.